Here we're just going to simplify each matrice, and if it's not possible, we are going to explain why. So if there's no symbol in the middle of my matrices, that tells me that we are doing matrix multiplication, and again, that's different than our scalar multiplication. So from our previous video, we're checking the dimensions. Inside numbers have to be the same, outside numbers are the new dimensions, and then we're taking the rows times the columns. Okay. So I would like you to pause the video, see if we can multiply these matrices together. All right, so for problem 1, we have a 2 by 2 and a 2 by 2. So inside numbers are the same, so my outside numbers are the new dimensions. So I'm going to have 2 rows and 2 columns. So taking rows of the first matrix, columns of the second. Okay. So -3 times 1 is -3, plus 4 times 2 is 8. Then moving on, so now I'm using this column. So that will be 0 plus -12. And then here I'm in the second row, first column. So now I'm using the second row of that first matrix, first column of the second. 5 times 1 is 5. 2 times 2 is 4. And then now I'm using that second row and that second column and second row. So 5 times 0 is 0. 2 times 3 is -6. So if we simplify this, that will be 5, -12, 9, and -6. And make sure you guys are leaving enough spacing when you write it to make it clear what your rows and columns are and that we don't have this really big number. All right, next one. We have 1 row, 2 columns, 2 rows, 2 columns. So inside numbers are the same, outside numbers are the new dimensions. So I'm going to have 1 row, 2 columns. Okay. All right, so again, taking my rows of the first times columns of the second. So -3 times -3 is 9. 5 times -5 is -25. 5 times 1 is 5. Excuse me, should have done 3 times 1 first, so that will be -3. And then plus 5 times -1 is -5. So if we simplify, again, we are just combining those numbers together. So this will give me -16. And then -8. Okay. So it's important that we're not just rushing through this because it is easy to make a mistake like I almost did. So we, again, go through, check your multiplication, and check your signs. All right, looking at 3, we have 3 rows. So 3 rows, and then 1, 2 columns. So 3 by 2. And then this is a 2 by 2. So inside numbers match. That means that the outside numbers are my new dimensions. So this is going to give me 3 rows and then 2 columns. All right, so again, I'm going to circle the rows in my first matrix, and then I'm going to circle the columns in the second. Okay, so row 1, column 1 will give me -1 plus 0. Row 1, column 2 will give me 1 plus 0. Okay, I'm in the second row, so I'm moving down to the middle, back to my first column. -1 times -1 is +1. -5 times 2 is -10. And then second row, second column. So again, second row, second column. So that will give me -1 plus 5. And then moving down to my third row. So 0 times -1 is 0. 3 times 2 is 6. And 0 times 1 is 0. 3 times -1 is -3. And I am combining my like terms. So that will be -1, 1, -9, 4, and 6, negative 3 for our answer. And it is important that you are showing this step right here. So I do want to see that work on your paper, in your homework, and on your test. All right, here's a few more to practice. So again, I want you to pause the video, see if we can answer them. So here we have a 2 by 2 matrix, and then 3 rows, 2 columns. So rows, columns, so here we have a 2 and a 3. So those are not equal. So on this one, this is not possible. Okay. And then we would have to say that the columns are not equal to the rows. And this is implying the columns of the first matrix do not equal the rows of our second matrix. So you do have to write it in this order. Okay, so now I'm going on to the next one. So I have 2 rows, 1 column, and then 1 row and 3 columns. So inside numbers match, and that means I'm going to have a 2 by 3 matrix. So 2 rows and 3 columns. Okay, so again, rows of the first, columns of the second. So I'm taking 7 times 5, so that will give me 35. And then because I don't have a second pair, that means that we're not going to have any addition. Okay, so first row, second column. So 7 times 6 is 42. 7 times negative 1 is negative 7. And then now I'm in my second row, so I'm using negative 3 back to my first column. So this will be negative 15, and then negative 18, and positive 3. So since there's nothing to simplify, this is technically my answer matrix, but I'm just going to rewrite it without all the lines. So 35, 42, negative 7, negative 15, negative 18, and 3. All right, number 6. Here we have 3 rows and 3 columns, 3 rows and 1 column. So inside numbers are matching, and then our outside numbers are the dimensions. So that tells me that I'm going to have 3 rows and just the 1 column. All right, so again, I'm going to just start by circling the rows in my first one and the columns of my second. Okay. So again, we're just multiplying the corresponding parts. So 1 times 5 is 5, and then 0 times negative 4 is 0. And then because I have a third number, a third pair, I'm just going to keep adding that product. So that will be a plus 4. Okay. Now I'm doing my second row, first column. So 3 times 5 is 15, plus a negative 16, plus 2. And then now I'm down to my third row, back to my first column. So 0 times 5 is 0, plus 5 times negative 4 is negative 20, plus 6. Okay. And then now we're just simplifying that. So that will add up to be 9. So 15 and negative 16 is negative 1. Negative 1 plus 2 is 1. And then that will combine to be a negative 14 for my answer matrix. All right, last example. 1 row, 2 columns, 2 rows, 1 column. So my inside numbers match. So that means I'm going to have 1 row and 1 column. So that is possible to happen. Okay, so again, multiplying the row and columns. So 3 times negative 1 is negative 3, plus 5 times 2 is 10, and then we would combine that to get 7. Okay. All right, and that is going to conclude Section 6 over multiplying matrices. All right, so next we are going to be applying these rules and ideas into solving systems with matrices.